So far in this course, every time we've talked about a triangle, we've been dealing with right triangles. So starting in this unit, we're going to break that trend and we're going to start dealing with what's called oblique triangles, which is just a fancy word for saying there's no right angles in this triangle. So in general, if we're going to talk about the sides of a triangle that's an oblique triangle, then we just make up names for the angles, generally A, B, and C. And the side opposite each angle has the same letter name, just in lowercase. So for example, here's our angle A. The side opposite of that is lowercase a. Same with B and C. And that just means that we can all talk about the same components of that triangle, regardless of how we draw it, and we know exactly which parts we're talking about. So as we move through this unit, we're going to be talking about solving triangles, which is just a fancy, shortened way of saying we're going to find all the information about that triangle, all the side lengths and all the angles. So any information that's missing, that's what we try to fill in when we quote-unquote solve a triangle. So there's several different setups we could have. We could either have two angles and a side given. So that could be angle, angle, side, or angle, side, angle. So let's talk about what that means. If we have angle, angle, side, that would mean I have an angle, and then a side that's not in between them. So if you were kind of going along in either clockwise or counterclockwise order, it would be angle, angle, side, or angle, angle, side. Okay, for angle, side, angle, that's ASA, that would be if we have an angle and then a side between that and the other angle. So angle, side, angle. Those two setups, we're going to use the law of sines, which is what we're about to learn first. There's actually also a third setup that uses law of sines, SSA, so that's where we have a side, and then an angle that's not in between them. But that requires a little bit of extra work, so we'll get to that in a little bit. And then finally, if we have all three sides, or maybe two sides and an angle in between them, we'll learn later how to use law of cosines for that. So you don't have to worry about memorizing all of this right now. What we're going to focus on right now is just this setup right here, either angle, angle, side, or angle, side, angle. So let's go ahead and state what the law of sines is. If we're supposed to use it, we're going to need to know what it is. So if you have any triangle, doesn't matter if it's a right triangle or not, any triangle, then all three of these things are true. So in other words, this is equal to this, the first one's equal to the third one, and the second one's equal to the third one. So you can pick any pair of information that you want from that chain of equalities, that's going to work. You're also allowed to flip all of those equalities upside down, and it's still going to be true. Okay, so in practice, kind of one of our first steps for using law of sines is just deciding which two pieces of information do we actually want in this. Even though we have three, we don't typically use all three at the same time. So we're going to do some practice of solving a triangle. So they give us a triangle ABC with angles given for C and B, and they tell us what the side length B is. So the very first thing we should do is try to set up our triangle. So I'm just going to draw a triangle. It's not a right triangle. This is not necessarily even a good drawing at all. This could be way off. I'm just drawing a triangle somehow. Okay, so I've labeled this angles A, B, and C. I know that the angle C is 102 degrees. It doesn't matter that this drawing is terrible. I know that's nothing like 102 degrees. B is 29 degrees. Okay, that's terrible too. And then little b, that's the side across from big B, is 28 feet. So I've drawn my triangle at this point, and I want to decide which setup I have. So I have an angle, and a side not between those two angles. So this is angle, angle, side. Now looking back at our setups, this is one of the setups that just tells us to use the law of sines. So let's go ahead and make a little table that holds all the information that we have for this problem. Okay, so that's what we're going to set up first. So I'm going to draw big A, big B, big C, little a, little b, and little c. So let's see, big B is 29 degrees. Big C is 102 degrees. Little b is 28 feet. Okay, so this is just to kind of help me organize what information I have and what information I still need. Now one thing I can do right off the bat without any fancy math, I always know that the angles in a triangle sum up to 180. So A plus B plus C should be 180. So if I want to find the measure of angle A, I'm just going to do 180 minus 29 minus 102. Whatever's left, that should be my angle for A. Okay, so if I do that subtraction, I'm going to get 49 degrees. Okay, so without doing really any complicated math here, I know that the measure of angle A is 49 degrees. So I'm going to fill that into my table. What's left is I need to find little a and little c. So let's look at the equations I have. I'm either going to use something from this first set or something from the second set. If I'm trying to find the measure of a side length, that's a little a, little b, or little c, it's easier to use the equations that have that side length on top. So I'm definitely going to be going with something from here. Let's start by trying to find little a. Okay, so I want this, and I want to see some other set of information that I know everything. So for example, if I choose C and big C, I only know one of those two things, so I don't want that. Let's work with B and big B. Okay, so I'm going to set up an equation based on that. So A over sine A equals B over sine B. So let's fill in everything we know. I don't know little a, but I do know big A. I know little b, and I know big B. Okay, so if that's my setup, I want to find a. So let's just multiply both sides of the equation by the sine of 49 degrees. So if I can do this calculation, I'll have my answer. Okay, so let's just round everything to 2 decimal places for this problem. I would generally specify that on a test. So I'm going to make sure that I'm in degree mode. That's going to be important. Now I'm going to go ahead and do that calculation. 28 times the sine of 49 degrees divided by the sine of 29 degrees. Okay, so let's see what that is. I'm coming up with 43.59. And because I have units here, let's go ahead and put the units, which are feet. Okay, so now there's only one piece of information, and that's finding c over here. Now, if your temptation is to say a squared plus b squared plus c squared, I want to caution you against that. That only works for right triangles. Okay, so we don't have a right triangle here. All that stuff that we thought we knew before about how to find stuff in a triangle, we have to work with a new skill set now. So instead, we're going to use law of sines again. This time I want to find little c. So I'm going to do something involving this third part of the equation right here, c over sine c. And I want to pick something else where I know everything. So actually I have choices here. I could either do a over sine a, or I could do b over sine b. Just for some variety, sure, let's do b over sine b this time. Okay, so I'm going to write out what I just picked. We could have chosen the other way. It really doesn't matter. I want to find little c, but let's fill in everything that we know. 28 over sine of 29 degrees equals little c over the sine of 102 degrees. Alright, so let's multiply both sides by the sine of 102 degrees. So if I can find that calculation, I'll have c. So let's throw that in the calculator. I want to do 28 times the sine of 102 degrees, and then divide by the sine of 29 degrees. And it's always worth a double check. Am I still in degree mode? Yep. So this time I'm coming up with 56.49. And of course, I know the units, so let's put feet. So at this point, I found all the angles, and I've found all the side lengths, which means I have solved the triangle. So this is our first example of solving a triangle using law of sines. And we chose to use law of sines because our setup was angle, angle, side.